Welcome to the session. Today we will discuss the basics of centrifugal pumps. First, what is pump? A pump is a device that moves water from a lower level to a higher level. Pumps come in different types based on their structure and applications. Some common types include positive displacement pumps and negative displacement pumps, piston pumps, centrifugal pumps, axial pumps, and vertical turbine pumps. Among these, centrifugal pumps are the most widely used in industries and buildings. By the end of this session, you will have a better understanding of the basics. Let's begin. What is centrifugal pump? A centrifugal pump is a machine that converts rotational energy into hydrodynamic energy to move fluids. It is powered by an internal combustion engines or an electrical motor, connected through flexible or direct coupled drives. The most common type is direct coupled centrifugal pump with an electric motor. A centrifugal pump has three main parts. One is pump section, moves the fluid. Second, motor section, it provides power. And third, connecting section, it links the motor and pump. The main parts of a pump are the suction section and the discharge section. Water enters through the suction side and leaves through the discharge side. The impeller is the rotating part of the pump. It creates negative pressure on the suction side, lifting water from a lower elevation. When water enters the suction side, it moves to eye of the impeller, where its pressure decreases and velocity increases due to rotation. From the eye of the tip of the impeller, the flow area gradually increases, which helps raise the pressure again before enter the volute casing. The volute casing has a shape similar to diffuser, which converts kinetic energy into pressure energy by allowing water to pass through a widening section. As the pressure increases inside the volute casing, water is pushed out through the discharge section. The shaft connects the pump to the motor. This connection must be properly aligned either horizontally or vertically to ensure smooth operation and balance. Now let's move forward. What is pump seal? A seal is a centrifugal pump prevents fluid leakage from the pump casing along the rotating shaft. It ensures efficiency and prevent contamination or loss of process fluid. It is a most important part of a pump. The shaft connects the motor to impeller and water flows through the space between the impeller and the volute casing. There is a small gap between the shaft and volute casing which can cause water leakage. To prevent this, the gap is properly sealed using different type of sealing materials. The seal is installed in the space between the shaft surface and hole surface in the casing. It connects moving and non-moving parts, so it wears out quickly due to friction. There are many types of seals available in the market. We will discuss them in detail in future sessions. And brief discussing some most important seals are mechanical seals and gland packing seals and lab thick seals and leaf seals. Most common seals are mechanical seals. It is widely used in various applications. Next, we will discuss about the working principle of pump. We have already discussed the part of the pump. Now let's talk about its working principle. The liquid enters the pump through the suction side and reaches the eye of the impeller. Here the pressure decreases and the velocity increases due to the impeller rotation. The liquid then moves through the pump and enters the volute casing where the velocity decreases and pressure increases. Finally, fluid is discharged through the discharge section. From this, we can understand that two main parameters play a role in pump operation, which are velocity and pressure. That velocity determines how much is liquid is pumped, and the pressure determines the height or distance the liquid is pumped. These two properties are dependent and affect each other. Next, we will discuss an important parameter of pump, which is nothing but NPSH, is net positive suction head. That NPSH determines whether the pump will experience cavitation. Cavitation is the formation of vapor bubbles inside the pump which can damage the impeller. NPSH is defined in two different ways. One is NPSH available. This is the actual NPSH in the system. It depends on factors like vapor pressure based on liquid temperature, and second, suction level, which is nothing but from the water is pumped. Then third, friction losses, which is dependent on minor and major pipe losses. And the second type is NPSH required. This is a minimum NPSH needed for the pump to operate without cavitation. It is provided by the pump supplier and depends on the pump design and operating speed. In many cases, VFDs, is variable frequency drives, are installed to reduce pump speed without understanding NPSH properly. Changing the speed may or may not affect the NPSH value, and improper adjustment can lead to cavitation damage. However, this is a separate topic which we will discuss in later. Then the basic formula to calculate NPSH is suction lift. This is the atmospheric pressure minus suction lift minus frictional losses minus vapor pressure. Here that suction lift, everybody knows the atmospheric pressure. Then we go to suction lift. This is a depth from which the liquid is pumped. It is fixed during the design stage and usually cannot be changed. Then second subtractable element is friction head loss. This occurs due to piping design such as number of bends, valves and fittings. It is variable and depends on pump speed and pipe size. And the third subtractable value is vapor pressure head. This depends on the fluid temperature. If the vapor pressure increases, the liquid inside the pump may start boiling, create more vapor bubbles. This can lead to cavitation, which damages the impeller surface. In the previous slides, I explained how cavitation occurs due to low NPSH. Vapor bubbles form and collapse near to impeller blade surface. Over time, this erosion damages the impeller, leading to serious problems. Look at the images to see the effects of cavitation. Then why cavitation occurs? When the suction pressure drops below the vapor pressure of the liquid, cavitation occurs. For example, consider the following values. Atmospheric pressure is 1 kg per centimeter square, is nothing but 1 atmospheric pressure, and then suction head is 0.7 kg per centimeter square, and friction head is 0.1 kg per centimeter square. Then vapor pressure is taken from the steam table for corresponding temperature, which is equal to 0.05 kg per centimeter square, for example. Then the NPSH available is 1 minus 0.7 minus 0.1 minus 0.05, refers the previous slides for the formula, which is equal to 0.015 kg per centimeter square. Then the NPSH required given by the pump manufacturer, for example, is equal to 0.05 kg per centimeter square. Since NPSH available is higher, no vapor bubbles form and boiling does not occur. Now, if the friction head increased to 0.22 kg per centimeter square, for example, due to scaling or any corrosion inside the pipe, the new NPSH available becomes 0.03 kg per centimeter square. Since this is lower than the vapor pressure, boiling starts, forming vapor bubbles. This can damage the impeller surface over a time. This is due to this phenomenon the cavitation occurs. Next, we discuss about the causes of cavitation in pumps. First one, low suction pressure. This is caused by high suction lift or low fluid level leading to vapor formation. Then second, obstruction in the suction lines. Blockages like clogged filters, valves or excessive bends reduce flow. Then third reason is high pump speed. Increase velocity, it increases the velocity, lowering pressure and leading to vapor bubble formation. And fourth one is high fluid temperature. It raises the vapor pressure, making it easier for the liquid to turn into vapor. These are the four main important causes for the cavitation process. Once again, I am repeating, it is low suction pressure is based on the fluid level maintaining in the tank, and second is obstructions is purely related to frictional losses, and third one is uh, is purely related to pump speed, whether it VFD connected or rated speed like this. And fourth one is based on the fluid temperature maintained in the circuit line. These factors reduce the net positive suction head, causing cavitation which damages the impeller over a time. Next, the effect of cavitation in pumps. The first one is noise and vibration. The cavitation creates a loud rattling sound and excessive vibration reducing pump efficiency. And second, impeller damage. This repeated collapse of vapor bubbles erodes the impeller surface leading to pitting and wear. And third, pump failure. Severe cavitation can cause mechanical damage leading to complete pump failure over time. Cavitation reduces pump performance, increases maintenance cost and shorten equipment lifespan. Then how to prevent the pump cavitation? Increase suction pressure, raise the liquid level in the suction tank or reduce suction lift, lower fluid temperature, reducing temperature prevent vapor formation, minimizing cavitation tank, and minimize pipe friction losses. Use larger pipes, reduce bends and keep suction lines short and smooth. Then select the right pump. Choose a pump with a lower NPSH requirement for the system conditions. Thank you for listening. If you have any doubts, please leave a comment. Feedback is always welcome. Thank you.